Modeling of time. As we saw, time plays a fundamental role in finance. So we need to say a few words about the way we shall treat it in our equations to calculate values, mostly present values. In everyday life, time is treated as a continuous variable, and so it is in practice in finance. It is possible to lend money for a very short period of time. Banks lend money overnight, usually to other banks. It leads to calculations like this. If I lend you money at a rate R over a period D, if we have agreed on so-called simple interest, at the end of D, you have to pay me M, the initial sum I lent you, multiplied by 1 plus R. Everybody is familiar with this equation. But we may agree on a slightly different way for you to pay me back. We may agree that actually I lent you this money over 2 periods, D divided by 2, and you owe me at the end of D, M times 1 plus R over 2 times 1 plus R over 2, because at the end of D over 2, the first half of the period, you owe me this, according to simple interests, and you keep this sum, and therefore at the end of the second half, you owe me this. We may also agree that we shall make the calculations on the period D split into n subperiods, and this will lead to a calculation of the repayment M times 1 plus R over n to the power n. When n tends to plus infinity, this quantity, 1 plus R over n to the power n, tends to e to the power r, which with mathematical notations is written limit when n tends to plus infinity of 1 plus R over n to the power n is equal to e to the power r, where e is a famous constant in mathematics. It is roughly 2.718281813, etc. It is one of the important constants with pi and a few more, and this one is irrational. That is, this sequence of decimal places is infinite with no periodic pattern. This leads to the formula for continuously compounded interests. We may have agreed on such a calculation for the money you owe me back. If R is what will be called the interest rates over a unitary period D, but it will no longer be introduced in a calculation of simple interest, then the repayment after period T that you will owe me is calculated like this. It's M, the initial sum I lent you, to the power to e to the power r times t over d. And if d is conventionally 1, that's m times e to the power r times t. These were calculations in continuous finance. However, in this course in elementary finance, we shall not use continuous time. Time will be made of discrete steps of 1 year. This modeling with discrete time is simply for the sake of classroom explanations. In a first approach, indeed, discreteness is simpler to manipulate than continuity. So cash flows produced by a security or an investment will be represented like this. There's the timeline, but the timeline is actually made of steps, just like the positive integers. So there will be an initial cash flow or initial price called C0. Usually C0 will be a positive number, and in the equations we shall have minus C0. Then there will be a cash flow in 1 year, C1, a cash flow in 2 years, C2, in cash flow in 3 years, C3, etc., if there are more cash flows. Paradoxically, in more advanced mathematics, and so it is also in finance, continuity becomes simpler to manipulate than discreteness. And when we are familiar with calculus, the integral from 1 to x of dt over t is simpler than the sum for I equal 1 to n of 1 over I, that is the inverse of the integers. Let's consider a small digression concerning physics. Discreteness and continuity in physics. Energy was naturally considered a continuous quantity until 1900, when it was necessary to consider it fundamentally discrete to explain certain phenomena. And the same may actually happen to time. So this leads, of course, to deep questions like, but what is reality? Well, is it what we represent with our equations, more and more bizarre, or our equations are only an approach to, etc.? We shall not enter into these considerations. To summarize, we shall consider discrete time. This is for the sake of simplicity in explaining elementary finance, and in a more advanced course, time will of course be a continuous parameter.